last class which I gave. Anybody has done? What is the solution? Hello? Anybody has done it? So which I gave the problem which is, so this one, the signal x of t which is given. Okay, what is the signal? So it will be the square signal between -4 and -5, and -3 is 0, and -2 -1, and at 0 it is 0, and this is your x of t signal. And 1 and 2 it will be having negative square pulse. Okay, so this is the value 1 amplitude, this is 1, this is 2, 3 you will be having 0, again 4 and 5 you will be having the signal. So this continues, and this side also. So this is the x of t signal which is given. So now we have found out t also, which is 6, and omega naught which is equal to 2 pi by t, and which is equal to pi by 3. Okay, so this you have done. So have you found out the x of k? Anybody? What is x of k? Hello? Anybody have found out? Okay, so if you have not found out, we will try to solve this one. And what is your x of t? It is given. So since the period, if you take 6, so between -3 to +3, okay. So there is a signal between -3 to -1, and it is positive, and 1 to 2 it is negative. Okay, so that you need to take it amplitude, and you have to substitute it. So what you will get? So t is 1 over 6, that is t is 6, 1 over, it will give 1 over t as 1 by 6, and this period t we need to take between -2 to -1 and 1 to 2. Okay, so that you need to take it, and you have to write down the integral, the value between, that is -3 to +3, only these two values exist between -2 to -1 and 2 to 1. So corresponding amplitude values you need to take it. Okay, so if you take that corresponding values x of t, so we can take it as 1. Okay, so between this t we need to erase. So between -2 to -1, so this is even having amplitude 1 x of t, d power minus jk into omega naught we have find out, that is pi by 3 into t into dt. Okay, plus, so this is whole thing, plus integral from 1 to 2, so the value is -1, and we will get e power minus jk pi by 3 into t. Okay, so this is the signal we need to find it out. So now find out the integral. So this one, 1 over 6 into, so what is e power minus jk pi by 3t? So that integral if we evaluate, so we will get e power minus jk pi by 3 into t. So this divided by, So minus jk pi by 3. Okay, so this should be evaluated between minus 2 to minus 1 and minus, so this will be evaluated between 1 to 2, which is given by e power, so minus jk pi by 3 into t, so this divided by minus j into pi by 3 into, sorry, so into k. Okay, so this will be evaluated between 1 to 2. Okay, so now put the value of t and evaluate the expression. So what you will get, x of k, which is equal to 1 over 6 into, so what you will get, e power minus j, so k into pi by 3 into minus 1. Okay, minus e power minus j k pi by 3 into minus 2. Okay, so this divided by minus j k into pi by 3. Okay, so this is evaluated between minus 1 to minus 2 and minus, so another term, this one, so e power minus j k pi by 3 into 2. Okay, minus e power minus j k pi by 3 into 1. So this divided by minus j k into pi by 3. Okay, so since this is common to both the terms, you take it outside and try to evaluate this one. Try to evaluate this one. Jk pi by 3. So this is common term. So now what you will get, x of k, which is equal to, so 1 over 6 into, so this will become plus, so minus into minus it will become plus e power j k into pi by 3 minus e power, so j into 2k pi by 3. Okay, and similarly here minus of e power, so this divided by jk into pi by 3. Similarly here e power, so minus j k into 2 pi by 3 minus e power minus j k into pi by 3. Okay, so this divided by minus, so here also minus is there, minus j k into pi by 3. Okay, so this is the expression and you can find out the value, that is 1 over minus 6 j k pi by 3. So take the common term and you will get it as, so find out the value, so this one e power jk into pi by 3 minus e power, so j into k into 2 pi by 3. So here minus e power minus jk into 2 pi by 3 plus, so e power minus jk into pi by 3. Okay, so now you evaluate this one in terms of sin and cos terms. So you expand that those terms, you will come to know, so what are all the terms remains. Okay, so 1 over minus 6j into k into pi by 3. Okay, so expand cos of pi by 3, into, so cos of pi by 3 k plus j into sin of pi by 3 k. Okay, so this minus, so you expand this one, which is cos of 2 pi by 3 k, so minus j, sorry, minus, it's not minus, it is plus, because here it is plus, so plus j sin of 2 pi by 3 k. Okay, so this is the first term. Okay, and put out the next term, so this and this, so next term is minus again cos of 2 pi by 3 k minus j sin of 2 pi by 3 k. Okay, plus two more terms for this, so plus cos of pi by 3 k minus j sin of pi by 3 into k. So now see the which are all the terms it will going to cancel each other. Okay, so and write it down the remaining terms. So you can see here, so plus, so here it is minus j and minus j, so this will be get added and this will be, so you can see here, so minus j sin pi by 3 will get cancelled each other with this plus j sin pi by 3k, and this minus cos of 2 pi by 3 it will be get added, and this also minus and this will become plus, so this will get cancelled each other. Okay, so now write out the remaining things, so you will get the expression, so x of k, so which is given by, so 1 over 6 minus jk into pi by 3, so this into, so I will get it as cos of 2 pi by 3 2 pi by 3k, so these terms it will be 2 times it will come, so minus cos of pi by 3k. Okay, so this will, these two terms will become 2 times and it will get, so these terms will repeat from the earlier expression and you will get here, and you will get 1 over 3, so into, so this minus it will be in the earlier expression, so if you interchange these terms and you will rearrange that, so that will become positive and finally this will get the, so you will get this answer, so this will become 1 by 3 into, so cos of 2 pi by 3 k minus cos of pi by 3 k, so this divided by, so jk into pi by 3. Okay, so this is your x of k, so the expression, and so this you will get the final expression. So you can plot out the magnitude spectrum by putting the value of k from 0 to infinite values. Okay, so from minus infinity to plus infinity you can go on putting the values, you will get the magnitude spectrum and as well as the phase spectrum. Okay, so this is the expression you will get finally. So here as I said minus 1 by 3, if you in the previous expression, if you here if you reorder the, uh, if you reorder here, so by using this minus sign, okay, so which is there here, so which is there here, if you reorder this expression, So the cos 2 pi by 3, it is having minus sign, it will become plus, and this cos pi by 3 which is having plus sign, it will become minus. Okay, so that will give the final expression, this one. Okay, so just I multiplied that minus sign inside, so you will get the this term first and later this term. Okay, so is it understood? You rearrange the terms in between, so you will get this expression. Okay, so Deepika, you are asking minus 1 by 3, right? Hello.
Yes, sir.
So you take that minus sign inside, so you will get
Ah,
it.
yes, sir. Now I got, sir.
Yeah, so that you will get a cos of 2 pi by 3 plus. So like that. Okay, so now take another one and try to do it. So take this one, x of k which is given, find out the time domain signal for this signal which is given by x of k. So for this you need to find out the time domain signal whose fs coefficients which is x of k, which is given by j into del of k minus 1 minus j into del of k plus 1, so plus del of k minus 3 plus del of k plus 3, k plus 3. So where omega naught which is given it as the value pi. Okay, so now find out the expression or find out the signal x of t, the time domain signal. So we know x of t expression which is given by summation k equal to minus infinity to plus infinity x of k into e power jk omega naught t.
Sir,
Yeah, is the screen is visible? Hello. Okay, so this is the problem which is given. You have to find x of t. Okay, so the whose fs coefficients is given by x of k, which is equal to j into del of k minus 1 minus j into del of k plus 1 plus del of k minus 3 and del of k plus 3, and omega naught which is given, which is equal to pi. So now you have to find out the signal x of t. So we know the expression for x of t. So we just find it out by putting the values of x of k at particular value, because we have only at, so this del expression which is valid only at k equal to 1 and k equal to minus 1, k equal to 3 and k equal to minus 3. So there you will get the value amplitude 1. Put the corresponding values of k and find out the x of t signal. So try to find out. So this you can express it as the sum of these terms, which is j into, so if you put,
excuse me, sir.
yeah,
Screen is not visible, sir.
I put that. Okay, sorry for the disturbance. Okay, so this is the signal which is given, the Fourier series coefficients. So you need to find the x of t. So the x of t expression we know, so with omega naught which is given equal to pi. Okay, so x of t which is equal to, so summation minus infinity to plus infinity x of k into e power jk omega naught. So now substitute the values of omega naught and also corresponding values of x of k. So this expression is valid for k equal to plus 1 and this is valid for minus 1, and similarly this is for plus 3 and this is for minus 3, because this will valid only at this k values. So now if you write this all this in terms of this coefficients, so you will get if so x of k, so if you take the x of 1, okay, x of 1, so I can write that also, x of 1, okay, into e power j into 1 into omega naught, which is given it as pi into t, okay. So this is x of 1. Similarly plus x of minus 1 into e power j, which is k is minus 1 and your omega naught is pi into t. So plus similarly you write x of 3 e power j into 3 into pi into t plus x of minus 3 into e power j into minus 3 pi into t. So now these are all the coefficients we can able to express using this expression which is given. So now your x of t signal is given by, so now you substitute the amplitude values, that is Fourier series coefficient values, that is which is given x of 1, okay, these values. So amplitude here it is 1 and here it is 1. So now you substitute the coefficients, so which is given by x of 1 is j, and you can write this one as e power j into pi t. So x of minus 1 is minus j, so this is minus j into e power minus j pi t, okay. So similarly plus x of 3 is 1 into e power j 3 pi t and plus 1 into e power minus j 3 pi t. So this is your x of t signal, and you can write in terms of cos and sine signal and evaluate the expression. And tell me what is the uh, expression, final expression. So if you take out j common here, you will get e power j pi t minus e power minus j pi t. So this you can express in some form, and plus this also you can express in some other form. So that is j3 pi t plus e power minus j3 pi t. So express this one. Have you got? Anybody got? So x of t, which is equal to, so now multiply and divide by 2, so you will get, so or you can take this j denominator, it will become minus, so minus of e power j pi t minus e power minus j pi t, so this divided by j, and if you multiply and divide by 2, so this you can express it as sine term, okay. And similarly you can express, so multiply and divide by, so 2, so you will get e power j 3 pi t plus e power minus j 3 pi t, okay. So take these two here and you will get this term we can express in terms of cos sigma. So you will get it as x of t, which is equal to minus 2 sine pi t, okay, plus 2 cos of 3 pi t, okay. So this is your x of t signal expression, final expression, that is minus 2 into sine of pi t plus 2 cos of 3 pi t, okay. So is it understood? Any doubt? Hello?
No, sir.
Okay. So now one more expression we have to derive, so that we have already seen in the symmetric property, so that we are going to derive. Okay, so in the symmetry property we have say that, so if x of t is the real value, okay, so if x of t, so if x of t is real valued signal, okay, if x of t is the real valued signal, so and if it is having a the fs pair, okay, so your x of t having fs pair with omega naught which is having x of k, okay, so if you have this one, so then prove that, so x star of k which is equal to minus, it is x of minus k. So this symmetry property when we are uh, discussed, so this we have discussed. So now how we can prove this? So take the expression of x of k, okay, take the expression of x of k, that is 1 over t. So this x of t is the continuous time periodic signal, so that t which is given, so for the x of t, and it is a real valued signal. So now x of t into e power minus jk omega naught t into dt. So this we know the x of k, okay. So now since the x of t is real valued signal, okay, since x of t is real valued signal, so then we can write, so whatever x star of t which is equal to x of t, okay. So now take the complex conjugate of this one, so both sides, whatever you are getting the complex conjugate terms, both sides you take complex conjugate. So because we need to prove x star of k equal to x of minus k, so this you take the complex conjugate both sides, we will get, so x star of t, okay, into, so if you take a complex conjugate it will become plus, so which is equal to jk omega naught t into dt, okay. So this will be given by 1 over t, so this time period t. So now x star of t which is, since it is real valued, so we can say that it is same as x of t, and you will get e power, so jk omega naught t into dt, okay. So now thus I can rewrite it as 1 over t, so time period t and your x of t, okay. So this I can rewrite it as, I'll write in terms of minus j, so need to compare with the x of k, so this I can write it as minus k. So if you multiply this and you will get the again plus jk omega naught t back, okay, so into dt. So now if you compare this equation with this equation, okay, so only the k term which is having minus, okay, so this we can write it as x of minus k. So your final expression x complex conjugate of k, so which will be given it as x of minus k. So if x of t is a real valued signal, then its Fourier series coefficients complex conjugate which is equal to x of minus k, okay. So this is a proof, so which we need to use for symmetry property, okay. So this is about the uh, proof, and take one more problem, which is, okay, so yesterday we have seen the like half wave rectifier kind of thing, that sine signal. So similarly you can use today the full wave rectifier kind of signal and try to find out what is the fs. So if the signal x of t is given it as, which is equal to magnitude of the sine of 2 pi t, okay, so this is a x of t signal given, okay. So now you need to find out what is the Fourier series coefficient, so which is given by like this. So this is 0 and this is half and this is 1. So similarly in the negative side also minus of and minus 1. Okay, so this is your x of t signal, and find out the Fourier series coefficient. So x of k you need to find it out. So try to find out this. So what is the time period? That is t, fundamental period. How much? Hello? Anybody? Try to tell me the answer for this. I will wait for 5 minutes. Try to find out the answer. Yashaswini, are you doing?
Yes, sir. Doing.
Yeah. Try to tell me the answer. X of k Fourier series coefficient. Pranita, Parinita, sorry, Parinita. Hello. Preksha, are doing? Lohit,
Yes, sir.
hello, Lohit. So I need to put lot of efforts for this solving these problems. So as the portion covered, so you will facing difficulties. You have to work out a lot. Okay. So what is the answer? Anybody got? So T is the time period is half, and your omega naught it will give 2 pi by 1 over 2, that is 1 by 2, which is equal to 4 pi. So now your x of k, which is equal to 1 over t, the time period t. So x of t into e power minus jk omega naught t into dt. So now you find out the expression for x of t, which is given sine 2 pi t, so which is equal to the period 0 to half. Okay, so you can write the expression sine of 2 pi t, which is equal to e power j into 2 pi t, okay, minus e power minus j 2 pi t, so this divided by 2j into e power minus j k omega naught is 4 pi into t into so dt. Okay, so this is the expression. So you will get 2 into 0 to half, or 2 by 2j you can take, so 0 to half e power j 2 pi t. So into e power, multiply this one, this term. So if you multiply inside, it will give minus jk 4 pi t. Okay, so minus e power minus j 2 pi t into e power minus j k 4 pi t. So this into dt. Okay, so this into dt. So now combine these two terms and try to integrate it. So if you combine, what will happen? So take out the common term. So j 2 pi, if you take out the common terms here, j into 2 pi if you take common term, and t also common term. So this will be remain it as 1 minus 2k. Okay, and here, so similarly you can take e power minus j 2 pi t common, it will remain it as 1 plus 2, 1 plus 2k. So you will get it as, so this will be equal to 1 over j into, so 0 to half, so e power j 2 pi into 1 minus 2k into t minus e power minus j 2 pi into 1 plus 2k into t. Okay, so this is the terms which we'll get. So now into dt, so integrate this one, so we will get x of k. So what you will get x of k? So we will get x of k which is equal to, okay, so 1 over j into, so e power j 2 pi into 1 minus 2k into t. So this is evaluated between 0 to half, this divided by j into 2 pi into 1 minus 2k. So minus e power minus j 2 pi into 1 plus 2k into t. So this divided by minus j 2 pi into 1 plus 2k into 2k. So this is 2k. So evaluated between 0 to half. So this will become, so both the j terms, so here can multiply and you will get it. So here, so evaluate the terms, so put the value of t of, it is 1 over j into e power j. So if you put t equal to 1 by 2, 2 will get cancelled and you will get j pi into 1 minus 2k. Okay, so minus 1, so this divided by j into 2 pi into 1 minus 2k. Okay, so here again, so e power minus, so if you put t equal to half, so you will get cancel each other here, j pi into 1 plus 2k, so minus 1, so this divided by minus j into 2 pi into 1 plus 2k. Okay, so now this minus and minus, so we can get cancel each other and you can put j inside, so you will get the final expression. So evaluate the final expression at least, to do the final expression, so you have to tell me the answer. So what is the x of k? I won't do it, try to do and tell me. So just rearrange the minus and plus terms and you multiply j term inside, and whatever you get you just put it. That is the answer. Okay, so you will be so if you multiply j, it will become j square, it will become minus 1, so minus this term, and here so j into minus j, it will become minus j square and it will become plus term. So if you multiply minus this 1 minus this term, it will become, and here it will be as it is there. So that is the answer. That is so 1 minus e power minus j pi into 1 plus 2k, so this divided by 2 pi into 1 minus 2k, so plus here minus, and similarly here, so we can, so this you can take, that is 1 plus 2k and this is plus 2k. Here e power j, so this, since it is multiplied, it will become minus, you can write it as 1 minus this thing, and 1 minus e power j pi into 1 minus 2k, this divided by 2 pi into 1 minus 2k. So are you getting this one? Anybody has a different answer? So this
Hello.
minus term, it is as it is there.
Yes, sir.
So because here if you multiply j into minus j, it will become plus, the minus it will be as it is. Okay, so that if you multiply inside, so you will get 1, so this 1 minus e power minus j pi into 1 plus 2k, so this term I am writing here. Okay, so this divided by 2 pi into 1 plus 2k, and here so this will become j into j, so minus, so if you again that minus if you put inside this, so 1 minus, so that it will become, so this is okay. Understood? So any doubt? So this is answer. So now try to evaluate one more problem and try to do it in the next class. Okay, okay, so do it this, try to do this one. So x of t, which is given by x of t, which is given by cos of 2t plus pi by 4. Okay, so this is a signal which is given x of t. So now we find out the Fourier representation and to find out the Fourier series coefficients x of k.
Not easy.
So, so take this one. So x of t, which is given by cos of 2t plus pi by 4. And try to find out the Fourier series coefficient. Okay, so we'll stop here and try to tell me the answer. I won't solve this problem, you have to tell me the answer. Okay, so we'll stop here.